In this video, a review of two touch-controlled LED lights for use in, for example, a camper van. So far I was using normal LED lights in mine, which I modified with a small tactile switch on the back to be able to control them by pushing them. But this was a lot of work to get all the distances right, and they remained a bit fragile and messy in any case. Since I switched my 12-volt system over to a 24-volt system, I needed new LED lights anyway, so I decided to check out some that can be controlled by touch. I already looked at this type in the past, but at that time the reviews I read mentioned a buzzing sound, so I stayed far away from them. I'm happy to report that this seems to be a thing of the past. The first one I will be looking at are these 9.5cm dimmable ones. They are usable in a voltage range from 9V to 30V and give a warm white light of 3000 Kelvin. They are also available in a 15cm variant, but for me the 9.5cm was already very big compared to my old ones. In the package we have the LED light and two borders, one in white and one in grey, which pop on to cover the screw holes. They come with about 25cm length of wire. Sadly, the electronics are potted, so you cannot see what's inside or fix them if they break. 3mm wood screws to mount the units are also present in the package. Note that once mounted and the borders are popped on, I suspect it's gonna be really hard to get them off without breaking some plastic clips. When measuring, the diameter is actually a bit less than spec'd at 9.4cm. These LEDs are also not of a recessed type. When installing them, they will stick out about 12mm from the ceiling, unlike my old ones that were almost flat with the ceiling. This might be a problem if you are restricted in height. Also note that the borders are just made of plastic and they are easily damaged. I bought the first LED for testing a few weeks ago and put it in a box with some other stuff while waiting for the rest to arrive. And as you can see, the paint got already scratched. Might be best to go for the white borders, so this kind of damage will be less visible. To control the brightness of the light, long press the control area of the LED. Depending on the previous state, it will either stepwise decrease or increase the brightness. A short tap on a control area will turn off or on the LED. It will remember the previously configured brightness when turning it on again. Note that the control area is limited to one specific spot at the side of the LED. At first sight this might seem undesirable, as it causes the LED and the control to be asymmetric. But it also has an advantage. Flying insects are attracted to these LEDs, and I have read reviews of people complaining that their centrally controlled LEDs are turned off by insects landing on them. I hope this will be less of a problem with this type of control. To be field tested in the summer. Now some power measurements. The left meter is for measuring the voltage, the right meter for the current. I cycled through the brightness range at 13V and at 26V, which would correspond to a 12V and a 24V system. At 13V, the idle current is about 2.1 mA, and the active current goes from about 30 mA at the lowest brightness to 193 mA at the highest brightness. I have to cover the light by a box a bit, otherwise the displays would not be readable by the camera anymore. At 26V we use about 3.4 mA of idle current, and the active range goes from about 20 mA at the lowest setting to 111 mA at the highest setting. From these values we can conclude that the energy efficiency at 26V is significantly worse than at 13V. It's not so bad that the internal voltages are made by an LDO, but it is not a very efficient DC-DC converter either. If you already have an efficient 12V DC-DC converter in your 24V setup, it's best to hook up the LEDs to the 12V rail. As a sanity check, I also verified that the light output is the same for both voltage regimes. Since I don't have a lumen meter here, I had to MacGyver something with a small solar panel to compare the outputs. The left meter measures the current going through the LED. The right meter measures the voltage produced by the solar panel, which is an indication of the amount of lumen produced by the LED. As expected, the solar panel voltage range for 13V and for 26V are identical. The next item is this slightly smaller touch LED at 7.3cm, though it is also available as 15 and 18cm variants. The lamp is just on-off, so it is not dimmable. It is sold as either 12V or 24V. I bought a 24V variant, and that one seems to work just fine at 12V too. I don't know if the reverse is also true. When measuring it, it is a bit bigger than spec'd at 7.4 centimeters of diameter. And it is again not a recessed unit, so it will stick out about 12mm from the ceiling, which is the same as the previous one. The lamp comes with wires that are around 23 cm long. The internal electronics are again not easily accessible. This time the control area is in the center of the lamp. The light color is not specified and I do not have a tool to measure it exactly, but I can tell it's much cooler than the other one, so more like 6000 K for this one. Now for the power measurements. At 13 volt the idle current is 4.5 milliamps and the on current is 190 milliamps. At 26 volts the idle current remains almost the same at 4.6 milliamps and the on current almost halves to 100 milliamps. Measuring the light output, this seems to give the same result as the max brightness setting of the dimmable lamp. I have summarized the results in a table. Personally, I will install lamp 1 types in my van, mostly because of the light color, but also because of the idle current. Before I did the measurements, I wanted to connect them to the 24 volt rail, but since I still have 12 volt too, and I have an efficient DC-DC converter for it, I will hook them up to the 12 volt rail. Except for maybe one backup light in case I'm working on my 12 volt and I disabled it. To round things up, one last quick test showing both lights in the same clip individually and at the same time so you can see for example a difference in light color.